So dy by dx is going to be dy d theta by dx by d theta. Just substitute there. This will be a theta sin theta by a theta cos theta. This is nothing but tan theta. Clear? Therefore, d square y by dx square. This step you have to be careful. This is d dx of tan theta. Okay? But there is a function of theta and you are differentiating with respect to x. So what you have to do there, you write this one as d theta of tan theta into d theta by dx. Most of the students do mistake at this step. They forget to write that d theta by dx term. Alright? So hope all of you will remember that as this one is a function of theta and you are differentiating with respect to x. So you need to multiply it by d theta by dx. Clear? So this will be sec square theta multiplied by d theta by dx. What is d theta by dx here? See this term? Dx by d theta we already got there. This part for dx by d theta by dx is reciprocal for it. There will be 1 by a theta cos theta. So it is going to be sec cube theta by a theta. Clear? Now so y2 we have got. At theta equal to pi by 4 we have to find its value. So just take when theta equal to pi by 4, d square y by dx square will be sec cube pi by 4 by a into pi by 4. Alright? Sec cube pi by 4 into divide by a pi by 4. You just simplify it. Sec pi by 4 is root 2. Root 2 cube by pi a by 4. Simplify it. It will be 8 root 2 by a pi. Clear? Hope you understand. So now I write the next problem for you. The next one is a bit difficult. I can discuss on the doubts for you. I cannot solve all the problems here, but all the types if I discuss, then you'll be able to do it at home. So we are taking one sum like this. If y equal to e to the power minus x sin x plus cos x, show that y2 plus 2y1 plus 2y equal to 0. In second order derivative, this is a very common type of sum which you can get. You just go through the sum. Have you checked? Hello. Just check once what to do. From my side, I can tell you, taking e to the power minus x on left hand side will be easier for you. Okay, just go through. I'll do. Just a minute. So how to prove this one? E to the power minus x sin x plus cos x. Show that y2 plus 2y1 plus 2y equal to 0. What you will do here, your best strategy will be, you take e to the power minus x on left side. It will be y into e to the power x equal to sin x plus cos x. Now differentiating with respect to x, dy by dx into e to the power x, e to the power x derivative e to the power x only. Derivative of this thing is what? Cos x minus sin x. Now what to do? What is the advantage? Because you got sin x plus cos x here. Next time if we differentiate, I can see that I am getting this term back on the right side. So there is a possibility that we can replace it by y into e to the power x. That I am going to do. So this implies e to the power x dy by dx plus y equal to cos x minus sin x, and now differentiating again, e to the power x into derivative of this plus dy by dx plus e to the power x derivative is e to the power x only, dy by dx plus y equal to, clear? This time we got back, so you replace it by y as y into e to the power x equal to sin x plus cos x. Clear? So there it will be e to the power x, this plus this will be common, 2 dy by dx plus y, and this also when you take on left side, y to the power x will be there, so plus 2y equal to 0. See what we have to prove? y2, 2y1, 2y we have got, because as e to the power x not equal to 0, therefore d square y by dx square plus 2y must be equal to 0. Clear? Understand? Now let us try to solve another problem of this kind, which you will like most, and hope all of you have the pen and paper with you and solving it with me. Okay? Then only this session will be meaningful for you. Okay? Just don't see it. Try to solve before I do. If not possible, do it with me. Clear? You all understand? So next I'm going to do this one. If y equal to x cube into log 1 by x, prove that xy2 minus 2y1 plus 3x square equal to 0. Clear? Understand? How do you understand? If you have done it, then only you have understood. Try to understand what to do. The very first step will be not to keep log 1 by x form. Apply the log property. When you are going to answer, you write y equal to x cube log 1 minus log x. Y equal to x cube, log 1 is 0, you know, minus x cube log x. Okay? Now differentiate with respect to x. What do you get? Minus x cube into log x derivative 1 by x minus 3x square into log x. Clear? Everyone understand? But the thing is that we have to remove log x from there. How to remove log x? We need to remove log x. How to? Will you differentiate once more? Of course you will differentiate. Just differentiate once more. Then you will get. Okay? Just differentiate once more. So there will be dy by dx minus x square minus 3x square into log x. If you differentiate once again, but before you differentiate, you need to check one thing, that we got the value of y here. What is y? Minus x cube log x. Minus x cube log x. So if you multiply both sides by x, multiplying by x, x into dy by dx will be minus x cube. Actually, second order derivative problems, mechanical calculation. Okay, just go on differentiating. No brain work required, believe me. You just go through my calculations and try yourselves. These are common sums given in all the books, all the good books. Good, I mean, all books are good. Good books are NCERT exemplar. Okay, Engage, R.D. Sharma. These sums are common. Okay, so you all can practice with me before you start sum solving from there. Hope you will be able to solve all the sums and stay till the end of the session. Okay, so This x cube log x I'll be replacing by minus y. X divided by dx will be minus x cube log x I replace by y. It will be minus. Now differentiate with respect to x. 1 into divided by dx plus x into d square y by dx square minus 3 divided by dx. Just take all the terms on left hand side, then you'll be getting the answer. Okay, I repeat, because this sum I was sharing link of this live session with some of you, that's why. So y is x cube log 1 minus log x, part is clear, minus x cube log x. Now use product rule for right hand side, minus x cube into 1 by x and minus 3x square log x. Then what I did, after simplification I have multiplied by x. So x divided by dx minus x cube is minus 3x square log x. Clear? This x cube log x we are replacing by minus y. Sorry, it will be plus y. Clear now? So you take this 3 divided by dx on left side. X d square by dx square minus 2 divided by dx plus 3x square equal to 0. Clear? And when I am doing, I may be wrong in one calculation. I'll accept your suggestion to solve it. Okay? I hope I haven't done any mistake so far. If I do it, human being, no, everyone can do mistake. Myself, even the author of the book also can do mistake. Believe me. Okay? If you bring their sum only to solve, they will get stuck. It happened to me. I have seen authors in universities, colleges approaching sums. They are thinking, so this should not happen. But if you say this should not happen, justified for you. From teacher side, I can tell you this can happen. Everyone in this world can do mistake. Okay? Even Looney's problem, particle dynamics, if Looney was alive and you have taken Looney's problem to S.L. Looney, he might have thought few moments. He is not in this world, the greatest author so far. Okay? I appreciate him most, S.L. Looney. Founder of very good books on trigonometry, coordinate geometry, the best book all over the world. Particle dynamics, this man will remain famous for next 1500 years at least because of these books. Particle dynamics one is excellent, you can go through one. Okay, let us go for the next problem. When there is, say, y equal to log of, I cannot answer, I cannot write the reply for during the class for all of you writing so many comments. It's good. I must go through all the comments you are passing over there. Then I'll give you the feedback. Okay. So this one, how to answer this problem. Y equal to this given, you prove that a square plus x square. Actually, I am a bit excited today. I am sharing this platform live the first time in my life. Okay, I have tried, but I did not get some. Hope in future I'll be able to continue this way so that all doubts in mathematics and physics will be solved here in this platform. Okay, including your board and JEE examination. And there is another thing I would like to say. I am teaching regularly for Olympiad also. I went live for them today. Those who are approaching for IOQM and RMO this year, they can go through the videos being uploaded regularly. Okay. This time I took the live session with them. I have explained number theory part 2. Part 1 done, part 2 I did. If possible, you go through one. Okay. It will help you for your JEE examination only. At least 3 to 4 sessions you need to see. Only 2 sessions I have completed there. Okay, let us go through. To prove this, what you have to do there, just differentiate once. dy by dx will be, derivative of this thing is 1 by x plus root over x square plus a square into derivative of this thing. What is derivative of x? You know, 1, and this one half to the power minus half into 2x. Clear? You understand? So dy by dx going to be 1 plus x by, you understand all the steps? Till this part you have done in class 11 only. Okay? If you remember, I'll tell you, you have done this in 11 in common books. Even this sum is there in NCERT exemplar book. Okay? It will be root over x square plus a square. Clear? Now these two are getting cancelled. It is 1 by root over x square plus a square. Okay? Most of you will like to differentiate at this step and then put the value of y2 and y1 over there. But I'll tell you to see the method I am using here to get this kind of sum very quickly. Just cross multiply root x square plus a square dy by dx equal to 1. Squaring both sides. What do you get? X square plus a square y1 square equal to 1. Isn't it? This you understand what I did there? I have cross multiplied and squared both sides. y1 stands for dy by dx. Okay. Now differentiating with respect to x, 2x into y1 square, x square plus a square 2y1 y2 equal to 0. For this kind of sum, what I tell you, once you cross multiply, square, differentiate and divide by 2y1, you get the answer. I'll show you in other examples. What I told you, dy by dx you got, cross multiply, square, then differentiate again. Clear? So now divide by 2y1. So there will be xy1 x square plus a square y2 equal to 0. I'll tell you again. You take your pen and paper and solve it with me. I'll give you the credit if you can solve before I solved here. At least you do it with me here. This session I am taking because of that reason. Students, those who are interested in this kind of live session, they will keep the pen and paper ready and practice with me. Okay? So let me tell you the next problem. Next problem is like y equal to sine log x. Then prove that x square y2 plus x y1 plus y equal to 0. Okay, y2 you are familiar, y1 also. To get this answer you will differentiate once. So you write dy by dx equal to cos log x into 1 by x. I have seen your calculation, in your calculation, that most of you prefer to differentiate after this step. Don't. What I told you in the previous sum, cross multiply, then differentiate. If required, you make square and then differentiate. So what you do here, you just cross multiply. X dy by dx equal to cos of log x. Alright? So differentiating with respect to x, 1 into dy by dx plus x d square by dx square. Derivative of this is what? Minus sine log x by x. See the advantage? The term you have started with, you got it back. So substitute there. X into dy by dx plus x square d square by dx square equal to minus sine log x, which is nothing but minus y. Clear? You understand? So just take on left hand side and you got the answer. Let us go for more difficult problems now. It is given that y equal to e to the power m sin inverse x when minus 1 less than equal to x less than equal to 1. Then prove that 1 minus x square y2 minus x y1 equal to m square y. Okay, how to proceed? You will differentiate once. Again the same manner. Do it before I complete here. And send me the report. Derivative will be m sin inverse x m by root 1 minus x square. Agree? This is again the previous two sums before. The technique we have used, cross multiply, square and differentiate. Okay? So root 1 minus x square y1 will be e to the power m sin inverse x. One thing before I do the next step, these kind of sessions I'm taking in YouTube on demand. What you told me personally or in a group, sir, do this topic, I am working on that. So one request already I have got on inverse trigonometric function, finding domain and range. Next session I will notify. 2-3 days I will remain out of station, but I will notify when I am going to take session on inverse trigonometric function, its domain, range, and my addition will be there, derivative of inverse trigonometric function. It is a very special topic. Okay, Apart from textbook, some difficult problems are there that I'll discuss with you in the next session in this platform. Whatever. So you got root 1 minus x square y1 equal to e to the power m sin inverse x. Now squaring both sides, what do you get? 1 minus x square y1 square equal to e to the power m sin inverse x whole square. Actually, e to the power m sin inverse x was y only, isn't it? So put it y square. Now differentiate with respect to x. Minus 2x y1 square 2y1 y2 equal to 2y y1. Clear? You understand? Now divide both sides by 2y1. Okay? So you got. So gradually we are starting few more difficult sums. I mean, how to solve. Let me take a problem like this where they have given y equal to a into x plus under root x square minus 1 to the power n plus and you have to prove that 1 minus x square y2 plus n square y equal to 0. Got it? How to prove? Another very good problem here. How to prove this? Y is given that way. A plus a into x plus root x square minus 1 to the power n and b into this. Prove that this thing equal to 0. How will you proceed? You can differentiate once, that is always done. Then what you will find? If you differentiate once, dy by dx will be na to the power n minus 1 into its derivative 1 plus 2 root x square minus 1 into 2x b into n x square minus 1 to the power n minus 1 1 minus 2x by, you understand? I haven't done anything new. The derivative we have done in today's class only, this type. Therefore, dy by dx will be na x plus into this root over x square minus 1 plus x nb, and here 2 getting cancelled. Same thing is there, root x square minus 1 out. There will be root x square minus 1 minus x. Now these two things can be multiplied in the numerator. This is going to be x square minus 1 to the power n by root x square minus 1, and here you take minus sign common, NB and then multiply to the power n, and this by root over x square minus 1. But you are supposed to get a plus sign so that it would have replaced by this. But sum is given this manner, what to do? So what we will do there, just cross multiply and differentiate once more. X plus NB, clear? So differentiating again, x square minus 1 d square by dx square plus 1 by 2 root x square minus 1 2x into dy by dx equal to, take this one out, na x plus root over x square minus 1 to the power n minus 1, and its derivative, what we did there, x plus root over x square minus 1 by root over x square minus 1. Clear? This minus NB n, same manner. This derivative we have done before. Can use the result. It is what? This by under root. Clear? It's a bit bigger problem. Now cross multiply by root x square minus 1. It will be x square minus 1 d square by dx square plus x into dy by dx equal to n, that 1 na already there, you have differentiated, there will be n square is common, a x plus root over to the power n plus, because minus I am taking common from here, okay. So this you now replace by what? You have taken this one as y, so replace it by y. Therefore x square minus 1 d square by dx square x dy by dx minus n square y equal to 0. Understood? I hope I am able to explain all the kinds of sums you expect in second order derivative. You start practicing from your book. I hope you will be able to do all the sums. Okay? So with this sum, I am ending the session. I will see you in the next session, probably on Wednesday, with the topic for which one some of you have, some of you have already demanded. That is, domain and range of inverse trigonometric function, and then I will take a session on derivative of inverse trigonometric function, but not the way you normally do it in school syllabus. Okay, this one, as per your CBSE requirement, some advanced sums we have done here might help you for other exams. Okay, thank you for staying with me.